Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am the teacher, Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View Channel 972. You are always welcome to join me live watching through the Zoom link. Whether or not you want to talk to me, that's fine. You can just watch. But the link is available for me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday, 10 until 11 in the morning. And we are in our 6th week of our 9-week course. At this point, you definitely should be submitting work for marking. So a reminder that the support questions, the ones with the little pencil icon, are not for marking. You decide which ones and how many to do. If you understand a concept, feel free to skip questions. You don't have to do them all just because they're there. The answers are in the back of your booklet. So I strongly encourage you to check your work before deciding that you don't need to do any of the practice problems. Check your work, do a couple, check your work to make sure you're on the right track. And then if you're really understanding and confident, then move on if you need to. The key questions, the ones with the little key icon, are the ones to submit for marking. So these ones, you need to do all of them. I'm marking them all, so you need to do them all, please. Also show all of your work, your steps, and your thinking. This way I can understand what it is that you understand. And if you are struggling with anything, then I can figure out what it is that you're struggling with and maybe why you're struggling with it and help you figure out how to improve. So the more information, the better. Please show your work. So how do you actually submit your work for marking? Well, there's 3 methods. The first is to scan your work and send it electronically. If you have a device, you can scan your completed work using that device. Apple devices have a Notes app, which has a scan function, and Android devices have a Google Drive app that has a scan function. These are free apps that generally come with these devices, and the scan function is fairly straightforward, basically just like taking a picture. But if you need help, on my YouTube channel, there are tech tutorials that walk you through step-by-step how to use these apps. So go check those out so that you can make your files a little bit smaller and easier to send, just to make life a little bit more straightforward. Then you can send them to me through email to studentwork@nnec.on.ca and CC it to me directly at bronwyn.slate@nnec.on.ca. Or you can also send it to me through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to drop right off into Lookout. We have an outdoor mailbox at 74 Front Street. We are the bright red building next to the post office and have a small white mailbox next to our side entrance. So check it out. Just put your work in there. I will get it back to you as soon as I can. The third method is to hand your work into your DEC. Your DEC can send your work through the Express, or they can also fax it to 807-737-1732, or toll-free fax to 1-800-463-7852. Sorry, students can also send in their work through fax. If you have access to a fax machine, that's fine. Just give us a heads up that it's coming, because sometimes things get lost in the shuffle with a fax machine. So if you have any questions and you want to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. So all of our radio Zoom classes are recorded, and I upload them to YouTube shortly after broadcasting and share them on Facebook, so you can find them there. It's all under a playlist called MBF3C, which is our course code. So everything is there, really easy to find. Also, there are short videos that explain common errors and confusing concepts. So that is a good place to go as well. In case you're struggling with something and you need a little extra help, go check that out so that you can set yourself up for success. Math is a really visual subject, so I strongly encourage you to access the lessons through the videos. So either joining me live through Zoom, again, you don't need to talk to me, that is fine. Just watching is great. Or watching the YouTube videos on your own time when you can pause things, slow things down, come back to them as needed. That is also a great option. So those are great. If for some reason they don't work for you, let me know and I can send you a copy of the recordings so that you still get the full experience and hopefully can set yourself up for the most success. So if you have any questions or concerns, you want to talk to me about anything, please let me know. Reach out to me through email at bronwyn.slate@nnec.owen.ca or through Facebook at bslate-wahsa. Send me or call me at the office at 807-737-1488, extension 2209, or also toll free at 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., though I teach from 9 until 11, so that is not a good time to try to get a hold of me. Today is a Throwback Thursday lesson. So we are going to be focusing on lessons 10 to 15, though, of course, with Throwback Thursday lesson, we are reviewing all the way back to the beginning of our course. So yes, we are about 2/3 of the way through our course. So you might not be asking why we're reviewing already, but you also might be one of the many folks who just cram the night before an exam or right at the end of your course. So remembering that according to research done by Herman Ebbinghaus, we forget things really rapidly. So reviewing things means that we retain that information. So after a day, we've already lost 20% of what we've learned. After a week, we've lost almost 60% of what we've learned. So reviewing is really, really important if we want to retain that information. If we do retain that information, not only do we remember more of it because we frequently revisit it, but we also remember it for a longer period of time. So we don't lose it as quickly. So this is why we keep coming back to reviewing every couple of weeks to just go back all the way to the beginning of the course to remember what it is that we've been studying. As I know that it's really easy to forget what we've done weeks ago because life is full and busy and we've got other stuff going on. But first, of course, let's activate our brain with some mental math and go from there. You know, I don't like mad math minutes. They cause stress and anxiety. They don't help anybody. I mean, maybe they help some people. They don't help the majority of us. So instead of focusing on speed and memorization, we work on developing skills that we can use in various situations and are based off of our own comfort and friendly numbers that work for us. Today's question is 308 plus 268, and we're using the strategy of compensation. So what compensation means is that if we take from one and add to the other, we're compensating. So how, with this question, I know that 8 is really close to 10, and if I take 2 from the other number and add to it, I will get 10, and then I'll have a friendly number, which 10 is a much friendlier number to me than 8. So because I have 308 and 268, both of them end with 8, I can, either one I can do this with. So I'm going to say 308 plus, and what I'm going to do is I'm going to break 266 plus 2, because 266 plus 2 is 268, because I want this little 2 over here. So then I can steal that little 2, and I'm going to do 308 plus 2 plus 266 equals 310 plus 266. And then now, to me, that's easier to see that that's going to be 576. Because I can just add up through place value. 300 plus 200 is 500. 10 plus 60 is 70. And 6 plus 0 is 6. So compensation is a great tool because if you can figure out your combinations to get your numbers to friendly numbers that end in 10, can really make your life a lot easier. You could also do it to make your numbers end in hundreds or whatever, depending on how big your numbers are. Or also if you're dealing with decimals, ending it in 50 cents or tenths or things like that can also be really helpful. Let's see if today I can change my color. So that's just a little bit easier to see against my text. Okay. And that is our middle math today. All right, so before we do some mixed practice, we are going to look at the highlights. We're just going to review at a glance what we have done so far this year. Remember, this is a quick overview of what we've done. Anything that you don't remember or you really struggled with, you need to go back to those individual videos and try to figure out it from those videos. This is just today, our focus is to remember what we've done since the beginning of the course and work on figuring out which strategy is the best strategy to use in question, because our questions aren't assigned to particular lessons. So it is not the time to learn, it is the time to review. If you need to learn, go back to the other videos and learn the different lessons. All right, Unit 1 highlights. So in lesson 1, all the way back to the beginning, we're looking at quadratics, and we first looked at transforming quadratics. So we were looking at the equation of a parabola, and we said that if the general equation of a parabola is y equals a times x minus h quantity squared plus k, well, a tells us the opening direction if we're opening up or down. H tells us the horizontal shift if we're shifting left or right, and k tells us the vertical shift if we're shifting up or down, so that we can get any parabola by just manipulating those three numbers. In lesson 2, we looked at polynomials and factoring. So we now manipulated our equation a little bit more using algebra. So with expanding our polynomials meant that we were multiplying according to the distributive law. So we made sure that every part was being multiplied by every part. We used algebra tiles, we used the box method, and your booklet uses FOIL. We briefly talked about FOIL as options. And then factoring is going the opposite way. So it means that we're finding the two binomials that result in the trinomial product. So the same idea, if you think about factoring in terms of if we just have numbers, we have variables, it's the same idea. We're looking at the pieces that multiply together to get to that final product. In lesson 3, we looked at solving and graphing quadratics. So figuring out how to graph a quadratic based on the table of values, based on the equation, but also that if we're solving for a quadratic, this means what are values of x result in y equals 0. So what are our x-intercepts? Where does our quadratic cross our x-axis? And this gives us different information. Then in lesson 4, we looked at exponent laws. So we stopped looking at quadratics and now we're looking at exponential information. So we had 5 different laws. Multiplication law was that if we have the same base and we're multiplying, we can add our exponents. With division, if we had the same base, we could subtract our exponents. We have a power of a power. So we have an exponent raised to another exponent. Then we multiply those two exponents. When we have a 0 exponent, that means our whole thing equals 1. When we have a negative exponent, it means we have the reciprocal of that base with a positive exponent. Again, these can be tricky. Go back and check out the videos if you need more review. In lesson 5, we looked at simple exponential equations. So we graphed them and we looked at how there can be really fast change. That's what exponential means, is really fast change. And it can grow or it can decay. It can get bigger or it can get smaller. And our formula is in the structure of y equals a times b to the exponent x. So our variable is in our exponent. Then in unit 2, we looked first in lesson 6, we looked at simple interest and linear growth. So we talked about how simple interest grows or shrinks. So it increases or decreases at a constant rate. And the formula is I equals PRT. Or if we're looking for the total amount, so if we're finding the interest, that is I equal PRT. If we're trying to find the total amount, we have our principal plus our interest. In lesson 7, we then looked at compound interest and exponential growth. So here our pattern increases or decreases at a constant ratio. So we're multiplying or dividing by the same thing each time. And our formula is A equals P times 1 plus R divided by N to the exponent NT. Again, go back and look at all those variables if you don't remember what they mean, because I will give you your formulas if you need them. If you have a situation where if you're tested, and if you're doing your exam instead of a culminating, again, you can look this information up. You have access to it, but you need to understand what they mean. So understanding how to apply it is more important than memorizing it. In this case, if you're looking for the interest, total interest that you've earned, you need to do the A minus P because you have your total amount to take away your principal. In lesson 8, we looked a little bit more deeply at the compound interest formula, and we looked at some special situations. So if we're looking at a word problem, it has to tell us that it has a compounding. It has to say compound somewhere in the word problem in order for us to know that we're dealing with compound interest. So that's super important to recognize. We were able to rearrange our formula to find either the principal, the interest rate, and the time. But we also had to use the nth root or guess and check strategies to find those different variables sometimes. And so that can be tricky and something to make sure you're comfortable with. In lesson 9, then we started to look at loans and RSPs. So loans are when you're borrowing money and you must pay back that money plus any interest. So your payments are either calculated based on the amount that you borrow, or the amount you borrow is based on the affordable payment amount. So you can only borrow a certain amount because you can only pay back this certain amount during your months. So we have 2 versions of the formula. Again, they're just rearranged algebraically. So it is the same formula, even though we have 2 ways to look at it. And again, these are tricky. You don't need to memorize them. You can look them up, but you need to understand the variables, what the variables are. With your RSP, this is something that when you're working, you pay into an RSP so that when you retire, then you get regular payments because you've made that investment so that you get, when you don't have an income, you have a regular payment set up. Investing early means that you get more interest in the long run, but it is better to invest when you can invest than to not invest at all. If you want to make contributions, we had formulas. So how much you would make in total if you made certain payment contributions, or how much your payment needs to be if you want to get a certain amount. And then once after you made your contributions and you retire, then you also receive payments, and the receiving payments is the same as the loan payments because you're getting the money back. It's making, this time is that the annuity, the RSP, is making a payment to you instead of you making a payment to a loan company. So these are confusing because they're very similar. So it's important to be comfortable with when you use different ones. Go back to those lessons to check that out if you need a more refresher. All right, so then the more recent lessons that we've done. In lesson 10, we looked at buying new and used vehicles and the costs. So we looked at how to calculate a monthly payment, which is the same as a loan payment, and how to complete a deal review. So how to figure out all the different parts that are involved in buying a vehicle. If you are buying a used vehicle, we looked at how to calculate the depreciation value. So how much your vehicle is now worth based on how the rate of depreciation, how much it loses its value. And then we talked about costs of owning a vehicle. So how to calculate fuel costs, how to calculate your monthly averages cost so you can plan and budget for it, looking at fuel, maintenance, insurance, and licensing fees, all things to be considering. And then that wrapped up unit 2. So then moving into unit 3, we started looking at trigonometry. So in lesson 11, we looked at the trigonometry ratios, the primary ratios, which are sine, cosine, and tangent, and how first it's really important to label your right angle triangle. Then you can use either remembering SOHCAHTOA or sine of your reference angle equals opposite over hypotenuse, cosine of your reference angle equals adjacent over hypotenuse, or tan of your reference angle equals opposite over adjacent. So you need to be comfortable with those ratios. And you can solve either for an unknown side using these ratios, or you can solve for an unknown angle, but you have to use the inverse function when you're solving for an unknown angle. Again, there's a whole lesson on how to do that. Also, key to remember for all of trigonometry, your calculator must be in degrees. This is essential, or else if your calculator says RAD rad or GRAD grad, they are in different units of measurement, and your numbers will make no sense to you because we are not using those units of measurement. Then in lesson 12, we looked at the sign law. So this, again, we talked about how labeling our triangles is super important. With our vertices, our corners have capital letters, and our sides have lowercase letters, and the opposites have matching letters. So across from each other, match. And this is super important for organizing your information. Then we use the sign law when either we know two angles and a side, or we know two sides and an angle, but the angle has to be opposite one of the sides that we know. And then we can use the sign law in either of these situations. They both work. We have two versions, but they both work in all situations. They're just rearranged like most of our other formulas. So if you're looking for angles, having your angle variable on the top makes you have to do less algebra. So sine A over A equals sine B over B equals sine C over C. Or if you're looking for sides, having the side, so the small letters on top, means you have to do less algebra. So little a divided by sine A equals little b divided by sine B equals little c divided by sine C. And that is the sign law and when to use it. Then in lesson 13, we looked at the cosine law. So the cosine law we use when we know two sides and a contained angle, or when we know all three sides. Again, we can use the version of the formula in both situations, depending on, but one is easier than the other, depending on, so that we don't have to do algebra as much. So we're solving for a side, then doing the version of c squared, because that's your side, solving for a side, equals a squared plus b squared minus 2ab times cos c. Or if you're looking for an angle, doing cos c equals a squared plus b squared minus c squared divided by 2ab. Again, calculator must be in degrees, just like to remind you. In lesson 14, we looked at trigonometry and how to solve problems. So first we had to figure out the different trigonometry strategy. So are we using primary trigonometry, SOHCAHTOA? If we have a right angle triangle, we're using the sine law. If we have two angles and one side, or two sides and one angle, which is opposite the known side. Or we're using the cosine law when we have two sides and one contained angle, or three sides. So you can see, based on all of these different situations, we should be able to solve, because we now have the sine law and the cosine law, there shouldn't be any triangle that we can't solve as long as we have enough information. Possibly we might not have enough information. We might need to find some of that information. But we have various options depending on the different combinations of angles and sides that we have. We also looked at the angle of elevation, which is the angle at sight level from the horizon, then up to an object, and the angle of depression, which is the angle from sight level to the horizon and then down to the object. So just because we look with our eyes and not with our feet, just a reminder of that. And then finally, we looked at lesson 15, which was creating nets. So nets are a flat version of a 3D object that can be folded to create that 3D object. Patterns is a flat version of the 3D object with the parts separated. So you can't fold it because parts are separated. They're different parts. And the plans are a flat version of a 3D object that shows the front, side, and top views. So it can be reconstructed. So you can't fold it. You can't create it from the flat version that you have directly, but it has all the information so that you can create that 3D object. Okay, mixed practice. We've covered a lot. We're 3/4 of the way through the course, 2/3 of the way through our timeline. We have one more unit to do, and then we'll be reviewing for your final culminating activity. But let's do some practice so that we can figure out if we know what tools to use and when to use them. Number 1, a ladder is resting against a tree. The foot of the ladder is 2 meters from the base of the tree. The ladder forms an 84-degree angle with the ground. How far up the tree does the ladder reach? To the nearest 1/10 of a meter. So because we have an angle, I know this is going to be some sort of trigonometry question. I don't know which trigonometry question this is going to be, which strategy I'm going to use yet, because I don't know the situation. So whenever we are problem solving with trigonometry, I believe drawing yourself a picture is the best idea, or visualizing it. For me, I need to draw it out. So I have a ladder resting against a tree. So I'm going to draw myself a tree. Again, we talked about how your diagrams do not need to be beautiful. And we have a ladder resting against that tree. Trees, we assume that they make a 90-degree angle with the ground, even though their roots are going to come out. But in terms of our angle, in terms of the angle that we're making with the tree, that's going to be a 90-degree triangle kind of hidden in there. The ladder forms an 84-degree angle with the ground. So I need to say, okay, that's not 84, 48, sorry, degree angle there. My picture is definitely not a 48-degree angle. It's much larger. That's okay. It's all good. Doesn't really matter. Your picture is not supposed to be precise. It's a sketch. The foot of the ladder is 2 meters from the base of the tree. So the distance from the base of the tree to the ladder is 4 meters. 2 meters. I don't know where my brain is. How far up the tree does the ladder reach? So we're looking for the height here. So I have right angle triangle. I'm looking for the opposite. I have the adjacent. As you can see, sometimes making your picture really big can be helpful. So I can use tangent. So I'm going to use my primary trigonometry because I have a right angle triangle. So tangent of 48 degrees is equal to opposite over adjacent. So tan 48 is equal to height, my h, over 2. So h is equal to 2 times tan 48 degrees, which is equal to, let's use a calculator. I do not have all of my, ratios in my head. It's not reasonable. So that equals 2.2 meters. The question says to the nearest 10th of a meter, so that's 1 decimal place. So the ladder reaches 2.2 meters up the tree. And there we go. So it was a primary trigonometry question and a problem solving question. Okay. Number 2, a flare is sent up as a distress signal. The path is modeled by the relation of h equals negative 4.9 times t minus h quantity squared plus 177.4, where h is the flare's height in meters and t is the time in seconds. How long will the flare take to reach its maximum height? What is the maximum height? So again, this, because I have a quadratic here, this is a quadratic question. So I know I'm going to be using my quadratic tools. So how long will the flare take to reach its maximum height? And what is the maximum height? Again, you don't have to draw a picture, but I really like to visualize. So I have, for some reason, I think it's a boat. It doesn't have to be a boat. A flare doesn't have to be in the water, but I have a boat. And I've sent a flare up and then it's come down, right? So I'm wondering the maximum height. What is this? And when does that happen? So if I think about the maximum height, if I look at my picture, I'm like, well, that happens at the vertex. So if I think about how my parabola has been shifted, well, it's opening down because my A is equal to negative 4.9. So that's why it's opening down. My H is equal to 6 because it's T minus 6. That means that my H is positive 6. And my K is equal to 177.4. So I've shifted it to the right 6, and I've shifted it up 177.4. So my maximum height is going to be at the vertex, right? Where that's the highest that it goes. So the maximum height happens is at 177.4 meters and happens at 6 seconds. Oh, I answered those in opposite order, but because I wrote out a full sentence, it should be clear. So it takes 6 seconds for the flare to reach its maximum height, and the maximum height is 177.4 seconds. Could be another way I could write it. So drawing that picture really helped me visualize and then extract the information that I needed. All right, so then part B of this question, a typical flare will stay lit for 7 seconds. What will the height of the flare be 7 seconds after it launched? Okay, so we know that it hits its maximum height at 6 seconds. So we know that it's going to be past its height at 6 seconds, at 7 seconds. But how do we figure out what the height's going to be at 7 seconds? Well, this is when t is equal to 7. So then we just put it into our formula. So h equals negative 4.9 t take away 6 squared plus 177.4. So when t is equal to 7, that means that we put in, substitute in 7 when we see t. Oops. So then using our calculator, yes, we can see that 7 take away 6 is going to be 1, but anyway, we could do this in our head, but I'm having a day, so I'm not. So you can put the whole thing in, that's fine. Sometimes you just need to do it all. Plus 177.4 is equal to 172.5. So height will be 172.5 meters when it goes out. There we go. All right. Part C, how many seconds will the flare hit the water? See, it thinks it's going over the water too. So here, when does the flare hit the water? How do we figure that out? Well, I've had my boat and I've set my flare up, comes all the way down. The water is here at 0, a height of 0, right? So when it's a height of 0, that means that h is equal to 0. So again, we can put that into our formula. So 0 equals negative 4.9 times t take away 6 squared plus 177.4. And now we're going to solve for t. So that means we're going to rearrange our formula, our algebra, in order to isolate for t. Divide both sides by negative 4.9. We get, now how I like to do it is I like to do all of my algebra and then do my then just put it all in my calculator at once. That's how I'm comfortable. You do not have to do it that way. It might look weird to you. and that's fine. You do you. That's the joy of math, is that there can be different ways of doing it. So I'm going to subtract, I'm going to add 6 to both sides. I'm just going to erase that so that, because I've run out of room. So T is equal to, so we have 6 plus the square root of negative 177.4. The joy of this with Desmos is that it's really easy to do. These not so nice things underneath are radical. So T is equal to 12 seconds. So, which makes sense. If it takes 6 seconds to get to the top, it's going to be 6 seconds to get down. So in total, it's going to be 6 seconds to get to a height of 0. There we go. Number 3. So that was a bunch of quadratic questions. Number 3, your car fuels consumption rate is 12.2 liters per 100 kilometers, and gas costs 1.65 liters in Ontario and 1.50 liters in Manitoba. It is 290 kilometers from Sioux Lookout to the Ontario-Manitoba border. Does it cost more to drive from Sioux Lookout to Winnipeg, which is 448 kilometers, or to Thunder Bay, which is 392 kilometers? So with this question, we have to assume that as soon as you get to Manitoba, we just assume that as soon as you get to Manitoba, you're paying the higher rate, or sorry, the other rate, the lower rate of gas. So, which is not exactly how it works, but just roll with it. So going to Winnipeg, we're going to pay for gas for the 290 kilometers in Ontario. We're going to pay for $1.65 for each of those kilometers. Then we're going to add that to the extra kilometers between Winnipeg and the border. So we have to subtract the 290 kilometers to figure out how much that is. And those are still kilometers. And those are going to be at $1.50 per kilometer. So again, you could write this out slightly differently and do it in different steps. I am doing it all sort of combined together in order to save us time so that we have more time to do other problems. But the math, you should get to the same place, even if you break up these steps. So that can cost you 700 and that doesn't seem right. Really? $715.50. Feels expensive. No. Okay, so Thunder Bay. Let's do Thunder Bay and see how different the numbers are. We're just paying the cost for Ontario gas. So $392 times 165 cents. Sorry, not 100. $1.65. So 392 times 165 equals $648. $46.80. Again, That seems really high. I don't know. Anyway, we're just going to go with it. That's the math. So it costs more still to drive to Manitoba, even though part of the way, because the distance is farther, it still costs more to drive to Winnipeg. All right, number 4. How much will Kalen owe on his overdue credit card balance of $652 if interest is compounded daily for 25 days at 18.5 annual interest rate? So this is a compound interest question because it says compound right there. So that's important to remember. So that means that we're going to be using the formula A equals P times 1 plus R over N to the exponent NT. Our variables are P, it's our principal, how much we owe, how much Kalen owes, $652. Our R is 18.5%. So that is equal to 0.185. Our N is compounded daily, so 365. And our T is 25 days out of a year, so 25 out of 365. So then we put them into, substituting in our values, into our formula. And again, you can do these as individual steps. I like to do them all in one go in my calculator. Feels like it saves me some time, and I am confident that I will do it correctly. / if I make a mistake, it's a calculator mistake opposed to a conceptual mistake, because I'm the teacher. It's good. So we get $660.31. So then we have to check, do we answer the question? The question says, how much will Kalen owe? So yes, Kalen will owe because it's not just asking interest. Kalen's going to owe that total amount. Oops. $660.31. So that was a compound interest question. Number 5, a fox population is declining by 1.8% per year. The population can be modeled using the formula P equals 210 times 0.982 to the exponent N, where P is the population after N years. Part A, use technology to graph this relation. So I used Desmos to graph this. So with Desmos, I went in and I put in, I put in my formula, P equals 210 times 0.982 to the exponent N. I think in Desmos, you have to use Y and X, Y instead of P and X instead of N, just because that's how it's set up. You have to use X and Y. And then I manipulated my axes so that I had, because it would give me something really symmetrical. And so I moved my axis so that I got something that was easier for me to read. And you can do that using the settings. If you want more help, just go ahead and play with Desmos. If you want more help, let me know. We can chat about it. So part B, what is the current fox population? So the current fox population is when time is 0, because it hasn't declined. We're talking about in the future. So when time is 0, our fox population is at 210. And what is the expected fox population in 8 years? So then we need to look at when 8 years is, and you look up your graph. And so to me, it looks like it's about, so 150 160, 170, 180. I would say about 180 foxes. And depending on your scale, if you go in closer, you might be able to get more an exact number. If you're farther away, you might not get as an exact number. So that's why playing with your scale is really important. But also, I would accept a number that makes sense. You also could put in, instead of looking at your graph, you could put in and find the exact value by putting n and replacing that to be 8, and then you could solve for p there, and you'd find the exact number. So according to the graph, it's about 180 foxes. If we look at the formula, we will get 181.6 foxes. So both are good options that work. So that is an exponential graphing question, interpreting a graph. D, when will the fox population be half the current population? So if our current population is 210, then half the population would be 105. So around here. So if you have a ruler is a really good tool to use. So about there, I would say, which looks to me that it's about 37.5 years. So using the graph, we can do that. Or we can, if we're saying P is equal to 105, we can put that into our formula. So 105, 210, 0.982 to the exponent n. So this is going to be 1/2 equals to 0.982 to the exponent n. Or you could say 0.5, maybe might be better. And then you can use our guess and check method to figure out what n is. So if you want to do that, you can. If you just want to use the graph, that is fine. So approximately 37.5 years. And we can even check. We say 37.5 years is our guess. So we could go and put as our n, we could say is 37.5. So if we do 0.982 to the exponent of 37.5, then we see that that gets us to 0.506. So it gets us pretty close to where we want to be. So we can use that as and then if you want it to be more precise, you could move it around a little bit from there. So combination of using the graph and your formula can be a great option. All right, I think we have time for one more. The communication tower is built on the slope of a hill. A surveyor 50 meters uphill from the base of the tower measures an angle of 50 degrees between the ground and the top of the tower. The angle from the top of the tower to the surveyor is 60 degrees. Calculate the height of the tower to the nearest meter. So again, this is a trigonometry question, and we need to figure out what it is that it's actually asking us. We're going to do that by drawing ourselves a picture to figure out what is actually going on. So we have a hill. We have a communication tower on the slope of that hill. We have a surveyor, a person is 50 meters uphill from the base of the tower. So they are, here, I'm going to change I'm going to make my hill not so steep. Might be easier to draw. Okay. So I have a person, my surveyor, and they are looking They are 50. No, that's wrong too. My surveyor is 50 meters uphill from the base of my tower. So they are up here. That's 50 meters. They measure an angle of 50 degrees between the ground and the top of the tower. So that means that they're looking up here. This is 50 degrees. And the angle from the top of the tower to the surveyor is 60 degrees. Do you want the height of the tower? Sorry. Sorry, I got a tickle in my throat. Okay, so we can see that we're going to be using the slime law for this. I think I've lost my voice, so we're just going to call it a day. If you have any questions, please feel to reach out.